Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will learn how to use the chain rule to solve problems. So let's have a go at this problem here. A spherical balloon inflated, radius increasing 2 centimeters per second, and we want to know how quickly its volume is increasing when the radius reaches 10 centimeters. So how would the chain rule help us here? Well, let's start by writing what we want to find in notation that's familiar to us. We want to know the rate of change of the volume with respect to time. dv dt is what we actually want to find. So what are we actually told? Well, we're told the radius is increasing at 2 centimeters per second. So the rate of change of the radius with respect to time is just equal to 2. So how would the chain rule help us? Well, we know that by the chain rule, dv dt, I can introduce this other variable r, and I can write dv dt like this, dv dr times dr dt. Remember the chain rule, it's kind of like crossing out these two things. So I can find dv dt if I know this quantity and this quantity. Well, I know this quantity, it's just 2. What about dv dr? You probably think, oh, that'd be really hard to find. It's actually not. Because we were told that the balloon is spherical, it's a sphere, the volume of any sphere is 4/3 pi r cubed, where r is, of course, the radius. So dv dr, all that means is we take this function here and differentiate with respect to r. So we take the power of r, move it to the front, and then we're going to decrease the power of r by 1. So it'd be 3 times 4/3 pi r, decrease the power of r by 1. Of course, the 3's cancel out. So using the chain rule, we have the rate of change of the volume with respect to time is equal to dv dr, which is 4 pi r squared. That's what we found over here. And then we need to times that by dr dt, which is just 2. So in actual fact, dv dt is just 8 pi r squared. So if we substitute r equals 10 into this formula here, we get about 2513.27. So because the question told us about the radius in centimeters, the volume will be centimeters cubed, and because it was per second, the rate will be centimeters cubed per second. So what that means is when the radius hits 10 centimeters, at that instant in time, the volume is increasing by about 2,513 centimeters cubed per second. So that's an instantaneous rate. It's not an average rate. It's not how quickly the volume would increase over the first 5 seconds or anything. It's just how quickly it's increasing at the instant in time when the radius reaches 10 centimeters. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.